For more than a decade, green hydrogen has lived in a strange place. It has been praised as essential for deep decarbonization, mocked as inefficient and expensive, and repeatedly declared either the future or already dead. Yet, through every cycle of hype, collapse, and skepticism, one company has stayed unusually consistent in its conviction. While many players entered hydrogen opportunistically and exited quietly, Plug Power kept building. The question is not whether Plug Power has been right about everything. The question is why it continues to believe in hydrogen when so many others hesitate, delay, or walk away. The answer reveals something deeper about how energy systems actually evolve. Most critics of hydrogen focus on a narrow snapshot. They look at today's cost, today's utilization rates, or today's infrastructure gaps and conclude that hydrogen does not make sense. Plug Power has always looked at hydrogen differently, not as a standalone fuel, not as a replacement for everything else, and not as a quick win. Plug Power treats hydrogen as a system problem, one that only becomes rational when production, distribution, utilization, and reliability are designed together. This distinction sounds subtle, but it changes everything. From the beginning, Plug Power understood something many others missed. Hydrogen is not valuable because it is clean. Cleanliness alone does not create durable energy systems. Hydrogen becomes valuable when it solves problems that electricity alone cannot solve. That includes long-duration energy storage, high-utilization industrial energy, mobile power where batteries fail, and grid balancing under real-world constraints. Hydrogen is not competing with batteries in Plug Power's worldview. It is filling the gaps batteries leave behind. One of the earliest insights Plug Power internalized was that utilization matters more than headline efficiency. Many hydrogen projects fail not because the technology does not work, but because the assets sit idle too often. Electrolyzers that only run when renewable power is abundant struggle to amortize capital. Storage assets that cycle infrequently become financial liabilities. Plug Power focused early on applications where hydrogen systems could run consistently. Warehouses, logistics hubs, material handling fleets, and later heavy-duty mobility offered something rare in energy systems: predictable demand. This is why Plug Power's early success came not from power generation, but from forklifts. That decision puzzled many observers at the time. Forklifts seemed small, niche, and unglamorous compared to grid-scale energy ambitions. But forklifts run every day. They refuel frequently. Downtime costs money. Batteries struggled with long shifts, charging delays, and performance degradation. Hydrogen solved a specific operational problem in a specific environment with high utilization. Plug Power learned early that boring applications often teach the most important system lessons. Another insight Plug Power gained early was that hydrogen economics are dominated by balance of plant and integration, not just core technology. Too many hydrogen discussions fixate on electrolyzer stack efficiency or fuel cell chemistry in isolation. In reality, compressors, power electronics, thermal management, water systems, storage vessels, and controls often determine reliability and cost. Plug Power invested heavily in vertical integration, not because it wanted to own everything, but because it learned that system-level failures usually happen between components, not inside them. This system awareness also shaped how Plug Power thinks about infrastructure. Many hydrogen strategies assume infrastructure will appear first and demand will follow. Plug Power flipped that assumption. It focused on building demand anchors first, then scaling infrastructure around real users. This is a subtle but critical difference. Infrastructure built in anticipation of demand often underutilizes assets and burns capital. Infrastructure built to serve existing demand has a clearer path to scale. Plug Power's approach has been slower, but it has been grounded in operational reality. Another thing Plug Power understood early is that hydrogen is not a commodity at the start. It becomes a commodity only after standardization, scale, and reliability are achieved. In early stages, hydrogen behaves more like a service. Reliability, uptime, safety, and integration matter more than marginal price differences. This is why Plug Power focused on delivering complete solutions rather than selling components. It learned that customers do not want hydrogen. They want dependable power that fits into their operations without disruption. Plug Power also recognized that energy transitions do not move linearly. They move in fits and starts shaped by policy, infrastructure, capital cycles, and external shocks. Many companies entered hydrogen expecting smooth cost declines and rapid adoption. Plug Power prepared for volatility. It diversified across applications, regions, and technologies. This diversification was not about chasing hype, it was about resilience. When one segment slowed, others continued learning and generating revenue. A crucial insight that continues to separate Plug Power from many competitors is its understanding of time. Energy infrastructure operates on decades, not quarters. Hydrogen systems take time to mature, optimize, and standardize. Plug Power has consistently signaled a long-term horizon, even when markets punished it for doing so. This does not mean every decision has been perfect. It means the company aligned itself with the tempo of infrastructure rather than the tempo of financial markets. Plug Power also learned early that hydrogen must be physically present where energy is consumed. Unlike electrons, hydrogen molecules cannot move instantly across wires. Compression, liquefaction, transport, and storage impose real costs and constraints. This is why Plug Power has invested in distributed production and regional hubs. Centralized megaprojects make sense on paper, but distributed systems often perform better under real-world conditions, especially when reliability and redundancy matter. Another underappreciated insight is that hydrogen systems fail differently than battery systems. Batteries degrade predictably over cycles. Hydrogen systems tend to fail at interfaces under transient loads or due to contamination and thermal stress. Plug Power accumulated years of operational data in the field, learning how systems behave under imperfect conditions. This learning curve cannot be shortcut by simulations alone. It requires deployment, failure, repair, and iteration. This operational experience also shaped Plug Power's view on cost reduction. Many hydrogen cost models assume clean learning curves driven by scale alone. Plug Power learned that costs drop fastest when designs are simplified, standardized, and hardened against failure. Reducing part count, improving maintainability, and designing for serviceability often matter more than chasing marginal efficiency gains. These lessons only emerge after years of operating systems in messy, real environments. Plug Power also understands something uncomfortable about hydrogen economics. Subsidies help, but they do not replace fundamentals. Policies can accelerate deployment, but they cannot fix poor utilization or unreliable systems. Plug Power has benefited from policy support, but it has never built its strategy on subsidies alone. It has consistently emphasized commercial customers, operational savings, and productivity gains as the core value proposition. Another insight that sets Plug Power apart is its understanding of where hydrogen does not belong. Hydrogen is not suited for everything. Plug Power has never seriously argued that hydrogen should replace all batteries or power all passenger cars. It has focused on segments where hydrogen's weaknesses are manageable and its strengths matter. This restraint has helped it survive periods when hydrogen narratives became overly inflated and then collapsed under scrutiny. Plug Power's long presence in the hydrogen space also gave it a unique view of competition. It has watched companies enter with aggressive claims, raise capital quickly, and then quietly pivot away when reality set in. This experience reinforced the importance of patience and incremental progress. Hydrogen rewards persistence more than speed. The companies that survive are often the ones that move slow enough to learn, but fast enough to adapt. Another thing Plug Power knows is that hydrogen adoption is constrained as much by human systems as by technology. Permitting safety standards, workforce training, and operational culture all matter. Hydrogen systems require new skills, new procedures, and new trust. Plug Power has invested heavily in training, safety protocols, and customer education. These investments rarely show up in headlines, but they determine whether systems scale safely. Plug Power also understands the psychological dimension of energy transitions. Many organizations resist change until pain forces action. Hydrogen adoption often accelerates after alternatives fail under stress. Grid congestion, battery supply constraints, long-duration storage gaps, and uptime requirements all create moments where hydrogen suddenly becomes attractive. Plug Power positions itself for those moments rather than trying to force adoption prematurely. As grids face increasing stress from electrification, AI-driven demand, and renewable intermittency, the value of flexible, dispatchable energy grows. Plug Power's long-term bet is that hydrogen will increasingly serve as a buffer in these stress systems. Not everywhere, not always, but in critical nodes where resilience matters more than theoretical efficiency. This is a systems view, not a technology pitch. Critics often ask whether Plug Power's persistence proves hydrogen's inevitability or merely stubbornness. The more interesting interpretation is that Plug Power learned early that energy transitions are not won by perfect technologies, but by adaptable systems. Hydrogen is imperfect. Batteries are imperfect. Grids are imperfect. The systems that survive are the ones that integrate imperfections into workable solutions. What Plug Power truly knows about hydrogen is that it is not a silver bullet. It is a tool. A difficult, complex, sometimes frustrating tool that only works when matched carefully to the right problems. Many others approached hydrogen as an answer. Plug Power approached it as a question. Where does this make sense? Under what conditions? And at what scale? That question-driven approach explains why Plug Power is still here. It explains why it continues to invest despite skepticism. And it explains why hydrogen, despite repeated declarations of failure, keeps returning to the conversation when systems hit their limits. Hydrogen does not win because it is elegant. It survives because it is useful under pressure. As the energy transition enters a harder phase marked by capital constraints, grid bottlenecks, and rising reliability demands, the lessons Plug Power learned early are becoming more relevant. Utilization matters, integration matters, time matters. Systems matter more than slogans. Hydrogen's future will not be decided by hype cycles, but by whether it solves real problems at scale. That is what Plug Power knows, and it is what many others are only beginning to learn. If you want to go deeper into how hydrogen systems succeed or fail under real-world stress, the link to H2 Hub by Renee Energy is provided in the YouTube description.